just pick a couple of them for us to do. Let's start with number 1. Okay, kind of easy here. It says the derivative of g times f. You can put brackets around this if you want to. At x equals -1. So we need to take the derivative, then we need to plug that in. That's the goal. Now, what rule is this going to require for me to dx it or take the derivative? Product rule. Very good. So my u is going to be f of x. My v is g of x. I'm going to put pr at the top for product rule. What is u prime then? F prime of x. And what is v prime? G prime of x. Okay? Then from there, you would say, okay, well then my derivative is this one plus that one, right? So it'd be f prime of x times g of x plus f of x times g prime of x. Now, they didn't give you like a name for this function, so you can name it, not name it, but I wouldn't name it like f because f's already a thing. So let's just call it maybe m. Okay, so if that's m prime, do you need this?
Yeah.
Okay, for you. It'd be m prime at -1 is what I want now, right? Yep, you're welcome. So m prime of -1, I'd just be pulling values out of that table. So m prime of -1 equals, you don't have to do this step if you don't want to. I'm going to because I'm feeling a little extra today. Okay, but you don't have to. You would just be doing that. And then you're going to find each of those numbers out of the table, plug them in, blah, 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 simplify. So what is f of -1? It is, oh, I'm sorry, I said it wrong. F prime at -1. 7. What is g of -1? 2 plus, what is f of -1? 4. And what is g prime of -1? 2. So that's 14 plus 8, which is 22. Good? Okay, let's say that we're doing letter C. What rule would that require? It would, oh, hint, quotient rule. Yeah, okay, so my high is going to be 4x squared. My ho is going to be, I need to write way smaller, f. Now, there were a couple people, I can't remember who it was, that were confused about it. If f is different than f of x. The answer is no, it's the same. So if you want to put f of x, that's fine. But if it's f, it's implied that x is the x value. Okay, then my d high, what's the derivative of the top? 8x. What's d ho, the derivative of the bottom? And then from there, I would take the derivative. Remember, it's ho d high minus high d ho. So ho d high comes first. So f of x and then 8x minus high d ho would be 4x squared. F prime of x, then over ho squared, which is f of x squared. And then from there, just like last time, I'm plugging in the x value that they've given me. They've told me again, just like last time, that x is -1. So now I'm going to plug that in. Okay? So this is now an f of -1. Look at your chart. What is f of -1? 4. What is 8 times -1 if I plug in a -1 right there? That's a -8 minus. Okay, then I come here. I'm plugging in a -1 to my x squared. What is -1 if I square it? That's a +1 now, right? And then times 4 would stay a -4. Now, be careful not to try to cancel those negatives out. Since the -1 I'm putting in here is squared, it can't cancel out with the negative on the outside. Okay, then what's f prime of -1 for that second part? It would be 7, good. And then divided by f of x squared, f would be 4 squared. Okay, so then that'd be -32 minus 28 over 16. What is negative 32 minus 28 more? Negative 60. So it'd be negative 60 over 16. And I'm going to leave it like that. You can reduce it if you want to. But if this was free response, where would I stop? 1, 2, or 3? You would stop at 1. That's good enough. Now, could you stop here before you've plugged in negative 1? No, but that would be perfectly fine for you to leave it like that. Okay, let's do maybe one more with an inverse. Let's do letter D. Okay, I want the derivative of f inverse. So I'm going to put f on this side. I'm going to put f inverse on this side. Now, for f inverse, what is the x value? For f inverse, what is the x value? 4. So it's 4 comma something. What would the ordered pair be then for the inverse, or for the original function? Something comma 4. And then I would look in my table for where 4 is an f value to find the x that goes with that. So come up to your table. Do I want this point? No, because 4 is a what? X. I want it to be a y. When is 4? Very good, at negative 1. Okay, so I filled in negative 1 down here. Next, I need to find f prime of negative 1. So look back at your chart. When f is 4, what is f prime? 7. And then remember that we know that the relationship between the derivative of a function and its inverse will be what? The reciprocal, so it'd be 1/7. Now, you don't actually need to fill this in, but you could if this is negative 1, 4. What's this one? 4, negative 1. Very good. Okay, but this is the answer that they're asking for. Now, I think later on in the packet it asks you to write an equation line, then you'd have the point and the slope to write that equation. Okay? Questions are good? Okay, I'll take the derivative for you on B, but I want you to plug it in on your own. Okay, what is the derivative of e to the f of 2x? E to the f of 2x times, what's the derivative of f of 2x? F prime of 2x times 2. So that would be your derivative. And now question, if you look at the table, will I be looking at the row where x is 2? No. When I plug this 2 in, here and here, what am I really going to be looking for if 2 is going into a 2x? I'll be looking at 4. Good. So this will be e to the f of 4, f prime of 4 times 2. So make sure that when you're evaluating here and here, that you're using the 4 row in your table. Okay? Okay, that being said, we're going to switch now to your notes. The notes I gave you yesterday, I think I told y'all, this is like a new AB topic, and I'm not really sure how to teach it best, so I kind of changed them. So if notes from yesterday, you don't even need to have those out. We're going to do the notes that you picked up on the way in. Some of the problems are the same, so don't go back and try to do those notes, or you're just doing a bunch of the same problems again.
What was wrong with the one from yesterday?
Nothing was wrong with them. I just kind of ordered them differently to try to make it like start easier and get harder. Versus when I threw all that in there, I didn't like scaffold it from easiest to hardest. Okay? All right, we're going to kind of jump around in this packet, but I want to start with the easy stuff first, because in second period I was thinking, oh, do the hard stuff first, and it was kind of a disaster. So, if you will, turn in your notes please to right here. We're going to start here. Okay, so number 6, look at it. Okay, we're going to plug in 2 because x is approaching 2, yeah? Okay, so when I plug in 2 on top, what do I get? F of 2 minus f of 2, which is 0. On bottom, I plug in 2. 2 minus 2 is 0. Now, can I put this? No, don't put that. Remember, you have to do the limits separately. So I'm going to write the limit as x approaches 2 of f of x minus f of 2 would be, I plug it in, f of 2 minus f of 2, which is 0. So far, so good? Okay, then on bottom, the limit.
Kristen, do you have to put f of x, or can you just put f of 2 minus f of 2?
Here, it should be f of x, but then when you plug it in, it would be an f of 2.
Do you have to write that stuff?
It depends. If it's multiple choice, no. If it's free response, then yes, you should. Okay, then this would be x minus 2. But then if I plug in 2 to 2 minus 2, I get 0. Now remember, if the top and the bottom both come out to be 0, that's an indeterminate form. That means that you take the derivative of the top and the bottom of the limit separately. What is the derivative of the top here? Okay, limit as x approaches 2 of f prime of x. Now let's talk about f of 2. Is f of 2 a function or a constant? F of 2 is a constant. We don't know what f is, but we know that f of 2 is the number I get when I plug in 2. So what will its derivative be? 0. Okay, on the bottom, what's the derivative of x minus 2? 1. Then what do I do from there? Take what x is approaching, try to plug it in again. Plug in 2 up here, what do I get? F prime of 2. Now, I didn't get it over 0, right? So that means that I know that I've found the answer. Okay? Let's do a couple more, then we're going to review something. Go to number 7. Okay, I want to plug in 3. That's my first step. I plug in 3 on the top. X approaching 3 of e to the x minus e to the 3 becomes e to the 3 minus e to the 3. Which is what? 0. I plug it in on bottom. The limit as x approaches 3 of x minus 3, well, that's 3 minus 3, which is 0. Whenever both limits come out to be 0, that's indeterminate. That means you need to take the derivative by L'Hopital's rule. So it would be the limit as x approaches 3 of, what's the derivative of e to the x? E to the x. What's the derivative of e to the 3, which is a constant? Over 1. Then what do I do with 3? Plug it in. E to the 3 over 1 is my answer, which is just e to the 3. Okay, one more like that, number 8. Okay, look at my thing. If I plug in x approaching 4, what would I get? I'm not going to write it this time, but what would you get? Plugging in right here. ln 4 minus ln 4, which is 0. On bottom, 4 minus 4 is also 0. So let's go ahead and just do the derivative step. So this is the limit as x approaches 4. What is the derivative of ln x on top? 1 over x. What about the derivative of ln 4? Because it's a what? Constant. On bottom, what's the derivative of x? 1. So really, it's just 1 over x. Then what do I do? Plug in 4. What would I get? 1 over 4. Very good. Okay, now I want to bring you back to something that you learned way at the beginning when we learned the definition of a derivative. Okay, f prime of a is the limit as x approaches a of f of x minus f of a over x minus a. This should look very similar to number 6 if you think about it, except instead of a being a generic number, what is a in this one? X is approaching 2. Okay, so you should recognize this is the definition of the derivative at a specific value of x. So we did this a long time ago, and I just want to connect the dots to it. If I had you circle f of x, we're going to do this one by the way we used to do it. Okay, f of x comes where? In front or behind of the minus? In front. Circle f of x. And then what would you do? You would take the derivative, then plug in what x is approaching, right? Because if this is f prime of a, then I'd circle the function, take the derivative, which is f prime, and then plug in whatever a is. You can do it either way. I don't care. You need to know how to do L'Hopital's rule. but knowing the derivative does make it a little bit shorter. Okay, so watch. Okay, circle the function, which would be what? Tan x. What's the derivative of tan x? Secant squared x. And then instead of an x, what is x approaching? Pi over 4. Very good. Now, can you see that that's what we did on the other two? We just did it the long way. Okay, look at this one. What's the function that I would have circled? ln x. What's the derivative of ln x? 1 over x. Then I would have plugged in 4. Okay, look at this one. My function was e to the x. Derivative is e to the x. Then I plugged in 3. So L'Hopital's rule is where that definition comes from. But if you remember the definition, then you can just do it more easily. Okay? Now, let's go ahead and solve this out just because we haven't done secant in a while. Secants, which one flipped? Okay, cosine. So pi fourths is here. Cosine's on top. What is cosine of pi fourths? Root 2 over 2. Now, if I want secant, I have to flip it. So instead of root 2 over 2, what would it be? 2 over root 2. And then remember that it is still squared, so I have to square the top and the bottom. What's 2 squared? What's square root 2 squared? 2. 4 divided by 2 is 2. Okay, look at the one next to it. We're going to do it the shortcut way. Okay, circle your function. What is it? Secant x. What's the derivative of secant x? Secant x tan x. And then what is x approaching? Pi fourths.
That's the derivative of secant is secant.
Uh-huh. Now, if you, I'll show you on the pink sheet just so y'all can see it. Okay, right here. Look at rule number 17. Yeah? Derivative of secant u is secant u tan u prime. Okay? And you don't have to memorize those. You get to use your pink sheet, but you should be trying to start to memorize them as we're using them over and over again. Okay? Secant, we just found. What was the secant of pi fourths? We just did that one. That was secant when I had squared it. So what was it in the middle? Okay, so that'd be 2 over root 2. Next, I need the tan of pi fourths. Pi fourths is here. What do you notice about sine and cosine? They're going to be what? Equal. And so if I do sine divided by cosine, but they were the same, I'll get 1. So it'd be 2 over root 2. Okay? Questions about that or good so far? Okay. Come down, please, to the next one. Okay? U prime would be the derivative of the middle, but since it was just an x in the middle, what's the derivative of x by itself? 1. But if it was like a 2x in there or something, you'd have to times by 2 at the end. Okay, come down to the next section. Okay, next one. What is my letter in the equation? It's not an x anymore, it's an h. So when I take the derivative, h is my x. Okay, so look at the first one. Okay, limit as h approaches 0. I'm going to plug into the top and the bottom. I'm going to show you the long way first, okay, and then I'll show you the shortcut. Okay, but it would be the limit as h approaches 0 of 2 plus h cubed minus 2 cubed. Okay, what is h approaching though now? 0. So if I plug in that h is 0, what do I get? 2 cubed minus 2 cubed. And that gives me what? 0. Okay, now if I plug in the limit as h approaches 0 of just h by itself, that's also going to be 0, right? No surprise there. So I get 0 over 0. That means we're doing L'Hopital's rule. Now, be careful. Your letter is h, not x. So on top, I have to do chain rule. H is approaching 0 of, I'm going to take the 3 times it down to the front. What is the new power on 2 plus h? Squared times. What is the derivative of h in the middle? Pretend it's an x. The derivative is not 0, 1. Because if it's x, the derivative is a times 1. So, in fact, I'm not even going to put the times 1, but we did chain rule, yeah? Now, what is the derivative of 2 to the 3? Because it's a what? Constant. Very good. On the bottom, what's the derivative of h if h is my main letter, kind of like x? 1. Then what do I plug in? H approaching what? 0 goes right here. I get 3 times 2 plus 0 is 2 squared, which is 12. So far, so good? Okay, let's do number 12. Look at the next one. Okay, derivative on top. I'm not going to make you show that step over and over, but let's plug it in to confirm that it's an indeterminate form. So if I plug in h approaching 0, what's this? E to the 1 minus e. Is e to the 1 minus e going to be 0? Yes. On bottom, plug in 0, I get 0. So take the derivative of the top and the bottom. Now that we've confirmed that it's going to be 0 over 0. Yeah, what's the derivative of e to the 1 plus h? It would be e to the 1 plus h times 1. Now, what about the minus e if e is a constant? 0. Divided by, what's the derivative of h? 1. Then I take my 0, plug it in. E to the 1 plus 0 is e to the 1, which is just e. Okay, look at the one next to it. Okay, if I plug in 0, I'd have ln4 minus ln4. On bottom, I'd also get 0 in determinate form. Take the derivative. Limit as h approaches 0 of, what's the derivative of ln 4 plus h? Well, the derivative, in case you don't remember, of ln u is u prime over u. So what's the derivative of u if it's 4 plus h? It would be 1 over 4 plus h. What's the derivative of ln 4 if it's a constant? 0. What's the derivative of h on the bottom? 1. Then I plug in what? I plug in 0. And I get 1 over 4 plus 0, which is a fourth. Yes, Kelly?
Why do you sometimes for the ln use that formula and sometimes you use 1 over x?
Because it depends if it's 1 over x or if it's the ln of x or the ln of u. So if there's anything other than just 1x, you're doing 1 over x, but if it's a u, that means you have to do chain rule. This is the chain rule form. Good question. Okay, bottom 2. Okay, look at your thing. What is the derivative of cosine? We're just going to assume it's 0 over 0 because it is. Okay, what would the derivative be? Negative sine of pi thirds plus h. And then by chain rule, the derivative of pi thirds plus h is just a 1. On bottom, what's the derivative of h? 1. Limit as h approaches 0. What do I get? The negative sine of pi thirds. Because if it's pi thirds plus 0, well then nobody cares, right? Pi thirds is here. What is the sine of pi thirds? Root 3 over 2, so it'll be negative root 3 over 2. Okay, I want you to look for the pattern. What did I do every single time? I took the derivative, then I plugged in the x value. Now, this one's a little bit tricky because instead of, okay, this is a constant, so when I take the derivative it's 0. Yeah. Okay, so here's the definition that we're doing over and over again without probably realizing it. F prime of A equals the limit as h approaches 0 of f of a plus h minus f of a over h. Now, this one is a little bit trickier to go backwards on because instead of it having an x in it, the number's already plugged in. So you have to almost kind of go backwards, which makes it a little bit harder. So I would do these based on L'Hopital's rule and not try to go back to the definition. But I will just for these last two since their trig it's easier. Okay, f is the function that both of these are plugged into. What is my f in 15? What's my function? Sine. What's the derivative of sine? Cosine. And then what am I going to plug in? Pi. Because remember, where's a in this one? It's already inside. Okay? So if that confused you, do it by L'Hopital's rule and you won't get it wrong. Okay? So let's do it by L'Hopital's rule. What's the derivative of sine on top? Cosine on top. Technically, there's a pi plus h still on the inside. Derivative of h on the bottom is 1. H is approaching 0. But then when I plug my 0 in, what am I taking the cosine of? Pi. What's the cosine of pi? -1. Very good. So, you have the shortcut there, but I think that for these, it's way harder to try to go backwards than to just do L'Hopital's rule. Okay? Turn the page one more time, please. Okay, when you get one like the next page, these guys. Okay, do you notice that you have two sets of letters? You have X's and you have H's. These are way harder to do by L'Hopital's rule. You should automatically recognize it as the definition of a derivative. So I'm going to give you the shortcut on this one first. H is approaching 0. F of x plus h minus f of x over h. That should look familiar because we've done this, unless BC kids, I don't know if y'all were in here yet. Okay, but we've done this over and over and over again. Here are your steps. You circle the function. Where is f of x? It's behind the minus sign. Is the minus sign part of f of x? No. And then you're going to do what? Take the derivative. So I'm going to start with number 20. Circle f of x in the definition. Where is f of x in the limit on number 20? Behind the what? Behind the minus sign. If it's x cubed, what's the derivative of that?
3x.
Done. Okay, don't use L'Hopital's rule. It makes it way longer. Okay, let's say I'm doing number 19 right next to it. Circle the function. What's the function in the derivative? E to the x. What's the derivative of e to the x? E to the x again. Okay, let's do 17 right above it. Circle the function. What's the function? Cosine x. Is it negative cosine x? Only cosine. What's the derivative of cosine? Negative sine x. Okay, let's do 18. Circle the function. What's my function? Square root x. How could I rewrite that? X to the 1/2. That's the same. And now take the derivative of it for me. That's going to be your answer. So my 1/2 is going to come down to the front. And x is now to the negative 1/2. Now, they're not going to leave it like that. 1/2 means a square root. Negative 1/2 means it's a square root on the bottom. So I'm going to rewrite that as 1 over 2 root x. And that's how you'd see the answer presented there. Okay, do number 22 for me. Because it was a 1/2, so the 2 was already on the bottom. Yeah? So 22, it's a 1 over x squared. How would I rewrite that? X to the negative 2. Very good. So take the derivative of that. My negative 2 would be in the front. X is now to the negative what, though, if I minus one more? Negative 3 or that. Your negative 2 stays on the top, but your x to the 3 moves into the denominator because it was negative. Okay, the last two I skipped because I want to make sure that you remember how to take the derivative if it's not a base e. So I'm going to write the rule right here. My function's obviously 3 to the x. If it's b to the u, the derivative is b to the u prime ln b. Do you remember that? You only have to do that if it's not an e to the u. If it's any other number to the u, you're using this rule. So what's the derivative of 3 to the x? It would be 3 to the x times, what's the derivative of x? 1. And then what's the ln I have to put at the end? ln 3. Now, do you have to write the times 1? No. So 3 to the x ln 3 would be fine. Okay, one more like that. Look at number 16. Okay, do that one for me. Circle your function, then take the derivative. Okay, my function is 2 to the x. What will the derivative be? 2 to the x times ln 2. You can put the 1 in there for chain rule if you want to, but you don't have to. Make sense? Great. Okay, now turn to the last page of your packet. Okay, which is on the back. So we learned yesterday that the indeterminate form is when you have what? 0 over 0. That's one of your indeterminate forms. The other indeterminate form is when you get infinity over infinity. Now, remember that for your limits to infinity, you should be using Bobo, Betsy, Botten, or whatever it is. Okay, those rules where you're seeing who's the biggest. Okay, but we're going to now prove that, which might seem pointless. We're not going to do all of them all the way out, but we have to do a couple of easy ones to do the hard ones. So, your rule here would be the limit as x goes to infinity of f prime over g prime. Now, if it works as you go to positive infinity, it also works as you go to negative infinity. The easiest way for me to have y'all do this is to think about the shapes of the graphs. Okay, so think about what's the shape on number 24 of x squared plus 5? What is it? Parabola. What's the shape of this one? Parabola. Okay, think about at the end of the graph as x goes to infinity, where's this one going? Up forever, which is infinity. Where's this one going? Infinity. Is it infinity over infinity? Then I can use my L'Hopital's rule. So you're going to take the derivative now, limit. X approaches infinity of 2x on top. What's my derivative on bottom? 6x minus 8. Okay, sketch the graphs for me. What shape is the top? A line. What shape is the bottom? A line. As x gets bigger, are both of your y's going to infinity? Yes, then I have to do L'Hopital's rule again. What's the derivative on top? Limit as x approaches infinity of 2. What's the derivative of 6x minus 8 on bottom? 6. What does that reduce to? A third. Do you remember Betsy, though? That's what you would have gotten if you did it the short way. Okay, so I would not do L'Hopital's rule on these because you already learned the Bobo, Botten, Betsy shortcut in pre-calc. What was it? Betsy stands for both equal, take coefficients. See how they're both x squareds? Then what would the coefficients be? 1 over 3. So 1 over 3 is the answer. That's where that comes from, but when you're in pre-cal, you have done derivatives, so you just learned it as a rule. Yes? It won't be in an FRQ. Now, harder ones it will be, and I'll show you some of those when we finish. Okay, now look at 25 real quick. What's the shape of this one? A line. What's the shape of this one? Parabola. As I go to infinity, are they both going up forever and ever and ever? Okay, this one goes like that. So yes, it's infinity over infinity. Then I get to use L'Hopital's rule, take the derivatives. So it'd be 3 over x squared, the derivative is 2x as x goes to infinity. Okay, from here, what is the shape of a constant graph? Flat. This one, draw a flat line. What about 2x? Which way is it going? It's going up. Is it an indeterminate form still? So then that means you have to make your decision. Which one's bigger? 3 or 2x? 2x, which means it's bigger on bottom. So where does it go to? 0.
Now we might as well do the Bobo box.
You should. I'm just showing you where it comes from. So yes.
We don't have to do the hot out.
You don't, I wouldn't do L'Hopital's rule on limits to infinity unless you need it, which we'll look at somewhere you would. Okay, real quick, look at 27. Okay, what does ln x look like? Goes like this, right? And it has an asymptote, it goes down forever and ever, but as I go to infinity, my graph is going up and up and up, yeah? Okay, what about x? What's its shape? Up. So are they both going up forever and ever and ever? Okay, then I'm going to take the derivative. What's the derivative of ln x on top? 1 over x. What's the derivative of x on bottom? 1, right? And what's 1 over x over 1? It's the same as 1 over x. And then from there I would think about my shapes. 1 is flat across. What's infinity doing? Going up to infinity. Then which one's going to be bigger? Top or bottom? Bigger on bottom, so it goes to 0. Now, do you remember when I gave you the classification of the sizes for all of them? Okay, what did I say about ln, which is a log, versus a power like x? Which one's bigger? Powers are bigger. If you don't remember that list, I'm going to rewrite it for you on here. Okay, but remember, when you're using Bobo, logs are the smallest, then powers like x or x squared, x squared, x cubed, and then exponentials are the biggest. So like e to the x, 2 to the x, etc. Okay, now, should you do it the long way with those? No, it's a waste of your time, okay, unless it happens to be a free response, in which case it'd be way harder and you'd have to use it. Okay, go to 21. If I take the derivative on the top, what's going to happen to e to the 2x? It would still be e to the 2x. What would the derivative on bottom turn to? 2x. Okay, so let's just kind of shorthand this. So my top would be e to the 2x times 2. My bottom would be a 2x. Now let's take the derivative one more time. What's the top now? E to the 2x times 4. What's the derivative on the bottom? 2. Now notice that in this case, is e going up to infinity? Is x going up to infinity? That's why I had to do it again. But then is e going up to infinity? Yes. Is the bottom going up to infinity? No, it's a constant. A constant is flat across. So then at this point you would say, okay, well if this one's increasing and this one's staying the same, then is it Bobo, Botan, or Betsy? Bigger on top is none, so it'd be DNE is correct. Okay, so this one, they're both still going up. This one, they're both still going up. But then when I get to here, that one's flatlined, so it'd be DNE. That's a good question. Do you remember what happens when it's going to negative infinity on an e? Okay, yes, but I want to show you. Can I show you with the graphs? Okay, e, which way is it going? As I go to negative infinity, what am I approaching? 0. Okay, and then as I come to this graph, which way is x going? Okay, it's going for infinity. Okay, so is that an indeterminate form? If this one is approaching 0 flat, okay, no, it's not. So then which one is going to be bigger? If this one is a constant and this one is going down forever and ever and ever, it'll be 0 because it's bigger on bottom. Now, one more time, let me explain to you why. Okay, some of y'all are confused. E is bigger, right? If I'm going where? To infinity. But if I'm going to negative infinity, what is E approaching? A flat line. It's approaching 0. Huh? Yeah, so think about though, you're seeing which one's getting bigger faster. So if this one is staying flat at 0, and this one is going down forever and ever and ever, then the bottom is increasing faster than the top. Now this is how I taught you to do it before we did derivatives. Okay, do you remember that when you plug the negative infinity into the E, remember we said this could happen? If it's E to the negative infinity, that it moves to the bottom. Do you remember that? And so then you'd still get 0 anyway. Okay, because the E to the X moves down because it has a negative in its exponent. So then it'd be 1 over E to the 2X times X as X goes to infinity. So whenever you have an exponential, if you're approaching negative infinity, that term shifts down. Okay, which is easier in my opinion to think about, but it still works with the graphs. Okay, we don't have that long, so we're going to do the hard ones tomorrow. Okay? You have several homework assignments that are due, your practice from Friday, then the homework you got yesterday, and the homework that you got on Monday. Those are the only 3 you're going to have though this week. Okay? And we'll finish the last examples on this tomorrow.